right, now we're going to cover 3.7, which is graphing linear inequalities. Again, how are linear inequalities different than linear equations? Well, linear equations have an exact answer. Okay, just like back when we were talking about, let's say if I have 2x is equal to 6 and I divide by 2, so this is not a linear equation, but I get that x equals 3. And that means that x is 3 and it's only 3 and it's this exact point. It's one dimensional, there's one variable, it's one dimensional, it's this point. But if I had this same thing as an inequality and I divide by 2, then I would get that x is greater than 3. So I'm not only talking about the points, the point 3, but I'm talking about everything bigger than 3. And remember, this is approaching a positive infinity. Okay, so there's only one specific unique point that would make this true. This is one dimensional because there's only one variable and that has just this point. Here there are multiple things, but we don't include the point 3. So what are some things to remember about inequalities? First thing is that we have to determine whether or not the value is included. So if I have greater than or less than sign, the way that we determine that here is we had a parenthesis. We say this parenthesis means don't include the value 3. But when we have a line, the way we're going to do that is we're going to make the line dotted. Okay, we're going to make the line dotted, and that's physically or visually going to be our reminder that, hey, points on this line are no bueno. Okay, if I have the equal to, then the line will stay solid. That is the same as a bracket. Okay, so just like right here, if this said 2x is less than or equal to 6, and I divide by 2, I get the x is less than or equal to 3, then that graph then would look like this. Okay, and I'd have a bracket on 3, and I'd be talking about all the values facing this way. Okay, and this, again, this parenthesis means 3 makes this statement false. So don't include it. So it's not included. But this bracket here means that 3 is less than or equal to 3, makes this statement true. So we have to include it. Okay, so going back to what we know about inequalities in general, equation versus an inequality, this is a specific point. This is all of these points but not including that one, and this is all of the points over here but also includes the point 3. When we're talking about a linear inequality, how does this change? I'm going to give the same type of examples here, but instead I'm going to say, what if I were given the equation y is equal to x plus 1 versus the inequality y is less than x plus 1, or the inequality y is greater than or equal to x plus 1. Well, again, this is just like how inequalities are different than equations. Well, if I were to graph this line, I would say, well, there's a bazillion points that I could make that lie on this line. If x was 1 plus 1 is 2, then y would be 2. If x was 2, then y would be 3. If x was 3, then y would be 4, and I could continue on, so on forever. And the way that I write the picture of all of the possible solutions of this line here is I go to the point 1, go to the point 1, 2, I go to the point 2, 3, I go to the point 3, 4, etc. And this line then looks like this. Okay, and again, every point that lies on this line are all of the points that if I plug them into here, all the ordered pairs. So like if I took this ordered pair right here, the ordered pair 0, 1, and I plugged in those values. Substitute 1 for y and substitute 0 for x, then this statement is true. Okay, so this line represents all of the possible ordered pairs that could make this statement true. This is a statement. It says y is all of that stuff. Okay, so this makes it true. So we're only talking about the line. But this point over here Okay, if I were to plug in the point 3, 2, 3, negative 2 is what that point is. 3, negative 2 into this equation. If I said negative 2 is equal to 3 plus 1, negative 2 is equal to 4. Well, no, it isn't. This is false. And that is why this point right here is not on this line. This line is the picture of all the possible solutions. Well, how does an inequality make this different? Well, where this line is not going to change. The line is going to be in the exact same place. Okay, so I can just use the same, because whether this says equal to, less than, whatever it says, the line will be in the same spot. So the line is going to be, okay, so the line will look like this. Okay. But you'll notice here that if I plug in, say, this point right here, which we found, which is the point 1, 2. So let's plug that into this inequality. 2 is less than 1 plus 1. This says 2 is less than 2. And you're like, wait a second, in here that was true. Well, that's because this line literally represents every ordered pair that makes the statement true. But right here, this one says that y is less than this. This is a false statement. 2 is not less than 2. So points on the line make this statement false. Okay, points on the line make this statement false. That means that I have to make this a dotted line. Okay, but I'm not only talking about points on the line, I'm also wondering, what if I plug in this point here, or if I plugged in this point here? Do they make the statement true or false? Okay, well, let's say this is negative 1, 1, 2, 3, 4. So this is the point negative 1, 4. And this is the point 0, 0. So let's plug those into this inequality. When y is 4 and x is negative 1, is this inequality true or false? 4 is less than 0. True or false? This is false. 4 is not less than 0. So points over here are false. But what if I plugged in 0, 0? Well, 0 is less than 0 plus 1. 0 is less than 1. Well, that's true. Okay, so the point that's not on the line right here makes the statement true. That means that everything over here is true. This is just like in my equation or my inequality before, when I was like, oh, it's all the points greater than 3, but not including 3 itself. Not including this line, but all of these points over here. If I plug in any point that lies on this side of this line here, it'll make this original inequality true. Okay, but points on the line are false. We plugged that in and showed you right here. Okay, so that's why this line is dotted. Well, how does this one differ from this one? The only difference here is that this one is not equal to and this one is. So again, where this line is not going to change. The line is going to be at the same place. I'm not learning how to graph a line differently. I'm going to say, oh my gosh, this line is going to be at these points right here. Okay, so this line is going to look like this, regardless of what these signs say. The line is there. But do points on the line make this statement true? Well, let's plug in this point right here. This is the point 3, oh sorry, the point 2, 3. Okay, that's on the line. So if I plug in 3 for y and 2 for x, then it says 3 is greater than or equal to 3. Well, that is true. So that means all the points on this line are true. So I'm going to leave this line solid to show that, hey, points on this line make this statement true. But I also want to know what else makes the statement true. Well, we already figured that out right here. Well, or did we? Let's see. So let's plug in the point, I don't know, let's plug in this point right here. Let's plug in the point 4, 4, 0 and see if this is true. Okay, so if I plug in 4, 0, I get that 0 is greater than or equal to 4 plus 1. 0 is greater than or equal to 5. No, 0 is not, so this is false. Okay, so points over here are false. So this point isn't true. That means all these points on this side of the line are not true. So let's plug in a different point. Let's plug in the point negative 3, 1. Just a point that's not on the line here. Negative 3, 1. Okay, so 1 is greater than or equal to negative 3 plus 1. 1 is greater than or equal to negative 2. Well, this is definitely true. So that means that all the points over here are also true. This is just like when we said we're talking about the points 3, and we're going to include the value of 3 and all this stuff over here. I'm going to include this line and all the points that lie on this line. Okay, so difference between an equation and an inequality. This was a long explanation, but the difference is that an equation is just the line, represents a solution. That's it. There's infinite number of possibilities, but points not on the line cannot make this statement true. With an inequality, I have to decide whether or not the line itself is true. It's going to be not true if there's no equal to. So it's going to be a dotted line. That's how I'm going to say, no, points on the line don't work. If it's equal to, points on the line are going to work. I'm going to make it solid. Okay, and then I have to decide whether or not I'm talking about the points above or below. Now, if the line is written in slope-intercept form, this literally says that y is less than all of this. So this is where y is getting smaller. Y gets smaller or is less below this line, so that's what's going to be shaded. Y is greater as we go up, so that's what's going to be shaded. Okay, so this is the difference between an inequality and an equation, a linear. Okay, so we're talking about lines here. But what are my steps for graphing? Well, first let's talk about a couple other tips. We want to remember that if we multiply or divide by a negative, note to self, if you multiply or divide by a negative, you should flip the sign. Okay, we may or may not use that rule, but just some things to remember about inequalities. Inequalities are not just a single solution. There's a lot of things that make them true. Okay, so what are my steps for graphing these? Well, if I'm going to graph a linear inequality, my first step is just to put the line in the xy coordinate system. So I'm going to graph the line portion using any method I want. What does that mean, using any method? Well, if it's easier for me, I can point plot. If it's easier for me, I can use the intercepts. And if it's easier for me, I can use slope-intercept form. Okay, so I can use any of these forms. Doesn't matter. So, but I'm just going to graph the line. Again, the line doesn't change regardless of whether there's a greater than, less than, equal to, whatever. My second step is I'm going to determine whether the line is solid or dotted. This is the easy part. The line is going to be dotted if there's no equal to. It's going to be solid if there's an equal to. I explained the reasoning as to why previously. The third step is I got to figure out where to shade. The way we're going to figure out where to shade is we're going to use a test point. And again, where we shade represents all of the values that will make all of the ordered pairs that if I plug it into the original inequality would make it true. So we're going to use a test point and we're going to shade the region that's true, and we're going to leave it blank if it's the region that creates a false statement. Okay, so these are my steps for graphing these inequalities. So let's go through a few examples here. We're just going to do like 4 examples and be done. Okay, so let's graph the inequality. Let's say x minus a 2y is equal to 4, but it's not going to be equal to. We're going to have an inequality. Let's say that it is greater than 4. Okay, so my first step is to graph the line using any method I want. Well, since this is in general form, I'm gonna use intercepts. So we're just gonna review intercepts. So if I plug in 0 for x, then what is y? When I do this, I'm gonna treat these like they're equal to, because these points don't change. Okay, so then I'm gonna divide by -2, and I get that y is -2 when x is 0. Okay, so that's my first intercept. Now I want to find my y-intercept, or my x-intercept. So I'm going to plug in 0 for y and see what x equals. Well, that goes away and x equals 4. So when y is 0, x is 4. Fantastic. So now I'm going to come over here and draw my graph. All right, so I have the point 0, -2, and the point 4, 0 on this graph. So the line looks like this. This line, again, does not change just because this is an inequality. So I graphed using intercepts, but I could have point plotted, or I could have solved for slope-intercept form. If I wanted to solve for slope-intercept form, I could do that. I could take, this is just an alternate way, I could subtract x, and divide by the -2. Here's where I have to remember this nifty rule that if I divide by a negative, I have to flip the sign. I don't like putting this in slope-intercept form just for this reason, because you have to remember the rules that I have to flip the sign here. Regardless, it doesn't really matter. I'm going to start at my point 0, -2, and from there I'm going to go up 1 over 2 and up 1 over 2. So you can see that this line would be the same regardless of which method you use to graph this line. Okay, now I'm going to determine whether this line is going to be solid or dotted. I'm literally just going to look at the sign. The sign has no equal to, so this line is going to be dotted. So I'm going to make my line dotted. That means that I don't include points on this line. Now I'm going to choose a test point. The easiest test point to choose if it's not on the line is 0, 0. Because when I plug in 0, 0, so I'm going to say, hey, is this point right here, is it true? Well, let's plug in 0, 0. If I plug in 0 for x and I plug in 0 for y, here's another tidbit. Always, always, always plug the test point into the original equation or inequality. Always plug it into the original, because if you forgot to flip this sign, you're going to mess up. Okay, so always plug the test point into the original equation right here. Okay, so then I just get that 0 here is greater than 4. Well, is 0 greater than 4? No, this is false. Okay, so I'm going to leave, this is the false region. I'm going to leave the false region blank. It's not going to have shading, but that means that if I plugged in a point on the opposite side, this would be true. So I'm going to shade the region that would be true. If this side is false, this side must be true. Okay, so that's what this would look like, graphing this inequality, going through each one of those steps. Okay, so I'm going to graph it using whatever method I want, solid or dotted, based on whether there's an equal to or not, and then plug in a test point. If it's false, you don't shade it, you shade the opposite. If it's true, you shade it. Okay, and again, always make sure you plug that test point in to the original equation. All right, let's do a couple more. Let's say I want to graph the inequality x is greater than or equal to a -4. Okay, well, I should recognize this by now. This is a vertical line. Okay, it's a vertical line, and I should know this. So what does this vertical line look like? Well, x is always -4, so it is going to look like this. Okay, and since it's at -4, again, this will be real quick if I recognize this. If not, I'm going to be in trouble. All right, so I've got a vertical line at x equals -4. Well, is the line solid or dotted? It's solid because there's an equal to, so it's going to be solid. And now, am I talking about the values to the right or to the left? Well, we can plug in 0, 0 because it's not on the line. There's no place to put the 0 for the y, so I'm just going to say 0 is greater than -4. 0 is greater than -4. Well, that is true. It is indeed true. So I'm going to shade the side that is true. So this would be graphing the inequality of a vertical line Points on the line make the statement true, and all the points on this side do. All the points over here, if you plugged in a point from over here, any ordered pair from over here would make this statement false. Okay? Okay, next one. Let's do y is less than 3/5 x minus 2. Okay, so my first step is just to graph this puppy. It's in slope-intercept form, so I'm going to just say, well, this is my slope, and this is my y-intercept. So this is my u, here point. So let's get on my graph. Okay, my u, here point is 0, -2. So this line is going to start right here, and from here, from this point, I'm going to go up 3, 1, 2, 3, and right 1, 2, 3, 4, 5. This is the next point on my line. Okay, so this is what my line looks like. Ooh, that's awesome. I almost went through exactly through those points. Okay, so line is on the graph. I used slope-intercept form here to graph this one. And now I want to decide if the line is solid or dotted. Well, looking at this, this is not equal to, so this line is going to be dotted. Okay, that's step 2. Step 3, I'm going to plug in a test point. Well, easiest point, because it's not on this line, is the point 0, 0. So I'm going to plug that in. I'm going to plug in 0 for y, and I'm going to plug in 0 for x, and see if this statement is true. 0 is less than -2. That is not true. 0 is more. 0 is greater than. So this is a false statement. So points on this side are false, which means then that points on the opposite side are true. Okay, so that is, I'm going to shade where it's true. All right. Last one. Let's do y, let's do a -4. Y is equal to 2x. Okay, well, I'm going to solve this for y, because that's going to be the easiest way to graph this. Oh, and let's not do equal to, sorry, let's do greater than or equal to. I'm going to divide by -4, so I'm going to get the y is greater than or equal to a -1/2 x. Great. Well, how is this going to go onto my xy coordinate system? Where is my u, here point? If I'm going to use slope-intercept form, my u, here point is 0. This is 0, so my point is 0, 0. Okay, so I'm going to start at the point 0, 0 here, and from there I'm going to go down 1 and right 2. Down 1 and right 2. Okay, so my line then looks like, wow, that is really straight and really great. Okay, so my line looks like this. Again, where this line is doesn't matter based on the sign. The line is the same. First step done, graphed my line. Next step, I want to decide whether this line is solid or dotted. Well, this is an equal to, so my line is going to be solid, so I'm going to leave it solid. Now I'm going to plug in a test point, and I recommended plugging in the point 0, 0, but the problem is 0, 0 lies on this line, so I have to plug in a different point. We can choose any point we want. I'm going to choose the point, this point right here, the point 3, 1. So I'm going to plug in the point 3, 1 into this original inequality. Substitute 1 for y and 3 for x. So I'm going to get that -4 is greater than or equal to 6. Well, that's false. -4 is smaller or less than. So this side is false. Okay, and this side is then what's going to be shaded. Now I want to point out something here. If I had tried to use this statement right here, that y is greater than, it actually says that I should be shading here. So I'm a little bit confused about how this happened. But what the problem is that when I divided by this -4, I forgot to flip the sign. This could happen to you. Okay, so just be aware, again, that we always, always, always want to plug in our test point into the original, because if we make this mistake, we will have the wrong graph. So don't plug it into this, plug it into the original, which we did, so we got the right answer. All right, so that is graphing linear inequalities.